Okay, we are examining domain and range in detail here, and we talked about the fact in our previous lesson that domain is all the values of x that we can possibly have for the relationship or function that we're talking about. And range is all the possible values of y that we are using in that function or relationship. So in this example, I have a circle, and if I look at the values of x that this circle is using, it uses the value from -6, and the circle is covering all of these values up to +2 on our x values. We're not using anything beyond 2 or before -6. So when I go to write this, I use a capital D to represent the domain. So domain is equal to, so the equal sign of course means equal to, and I just made a mess of that. Domain is equal to, so there's the equal sign. And then we talked on Friday about this curly bracket here. The curly bracket means the set of, okay, so that in quotes means the set of. The curly bracket is the set of x, so this x just means x. Now, beside that x is a vertical line. That vertical line is the words such that. Okay, so we've got the domain is equal to x, domain is equal to the set of x such that, now our values of x range between -6 and +2 inclusively. So when we write this, we want to say that we start at -6, so -6 is less than or equal to, it's smaller than or equal to the value that x can have, which is also less than or equal to 2. So really when I'm teaching this, I tell students, it's really that x here is sandwiched between -2 and 6, and we put the equal signs because we are including those values. For our x, and, so I'm putting comma for and, x, I didn't leave myself enough room here, so this would go in here, this is an up arrow just to say insert this, x is an element of, so we talked about using the epsilon on Friday, the real number system. So I use this boldface R, but because I can't do boldface very well with handwriting, I just use a double line there. So it's a member of the real number system. I'm using every single value between -6 and +2, and I'm not leaving any numbers out. So it's part of the real number system. Now, in terms of our y values, I'm looking at the y values, the range. My lowest y value here is -1, and my highest goes up as high as 7 inclusively. So I have R for the range is equal to the set of y such that my y goes between -1, so -1 is less than or equal to y is less than or equal to 7. So my y is sandwiched between the numbers between -1 and +7, and y is an element of or belongs to, so that's that epsilon symbol, which I'm making a mess of. Let me try that again. Y is an element of the real number system. Okay, so that's basically how we set this up. We've got a little bit more complication today in terms of making sure that we have all the notation correct here. So we'll walk through a couple more examples, and then I want you to put me on pause and try them, and then you can check your work. Okay, the second example here, I noticed that I have a line and it's going off with the arrows in both directions. So it really continues on forever and ever, amen, in both directions. So my domain is the set of x such that, and I'm not leaving any x values out. I'm going to use every single possible x number that I can think of, so I don't have to put any kind of limitation in like I did with the circle. We're going to use every single value of x, so our domain here is actually shorter. It's just going to be x is an element of the real number system, and the set with the curly bracket. Similarly with the range, my y values continue to go downwards. Go downwards this way. My y values continue to go upwards. My y values are going to cover every single possible value that I can think of in the real number system. My y is an element of the reals. Okay, if you want to try the next one, you can. Put me on pause, see what you can do, and then you can start me up again. Okay, checking this next one. My x values, my parabola is going to continue to go out and out and out and out for x values as it heads upwards. It's also heading kind of outwards. So my domain, I'm ending up using all x values again. So my domain is equal to the set of x such that x is an element of the real number system once again. Now, my y values do have a limitation on it. I don't go below this -6 point. So when I state my range, I'm going to have y such that my y is going to be bigger than or equal to -6. I don't have both an upper and a lower limit. I only have that lower limit. So I just start with my y, and my y is going to be greater than or equal to -6. And y is including every single value after that, so y is an element of the real number system after that. Okay, moving along to the next one. You can try it, and then you can put me on pause and see how you made out. Okay, looking at this one, I'm looking at my values for the x-axis. It looks like I'm starting at -4, and you notice that that is a filled-in circle. A filled-in circle is different than an open circle. The filled-in circle means we are including the value of -4. So -4 is included in this relationship. So it is included here. So when I go to state my domain, the domain is the set of x such that my x is going to be bigger than or equal to -4, and the arrow tells me it's going on forever and ever in that direction. So my x has to be greater than or equal to -4, and x is an element of the real number system. The range, if I look at my y values here, my y values look like they're starting here at -2, and again we're including that -2 because we have the closed-in circle, and then in this direction we're heading up and up and up, so we're going to go continue on in that direction. My y is such that y has to be greater than or equal to -2, and comma, y is an element of the real number system. And that was a really bad curly bracket. Let me try that again. There we go, that's better. Okay, so hopefully that makes sense. Try the next ones, and then you can watch the next video to check your answers.